off with last time? Get a little gains from trade. I just can't remember exactly. Got your notes handy. In terms of what?
I mean, we started with the fruit and then we recalculated it in terms of computer.
Okay. So we were, we showed the gains from trade in terms of both goods is where we got to. Okay. All right. So that is let me think here. I guess I think that's where we're going to leave that chapter. I think there might be one last little. So that's the classic Ricardian trade model. Yeah.
I was reading through the text over that chapter, and I don't know if we touched it or not, but what happens if the actual world price lands outside of the zone that we had said would make both countries better off?
Okay. No trade.
No trade.
Yep. Has to be in that zone.
Okay.
As long as we are keeping everything voluntary, then if trade is voluntary, both people are participating at their own will, and the only way they're going to do it, unless they're doing it for a handout, is to make both parties better off. Yep. So if it's outside that range, no trade. And so I guess a couple of you that are in spatial economics, the transaction cost wiped it out, right? So instead of one thing that could put it outside the zone is if we start to make it a little more complicated and say that trade costs money, that there's some sort of transaction cost, then that could nullify the gains. It could potentially wipe out the gains if the transaction costs were high enough. That's unlikely in the real setting, that transaction costs aren't usually that high to wipe out the gains. But okay, any other questions? So some folks added on to the Ricardian trade model and got a little more detail. So chapter 4 gets into a little bit more. I'm going to wipe this out, I guess. So since we're in international trade, we're going to get a little more complex. This marker.
So we're done with chapter 3.
Yeah, we're done with chapter 3. So this is chapter 4. You know, I meant it's not up. I meant to check it, but I won't do it this Sunday. We'll just make it probably Wednesday. This thing's either clogged or something. There's ink in there, but it's not like. So, modern trade theory is really extensions of the Ricardian trade model. As we uncovered, there was some simple assumptions in that model. So what was true about productivity?
It was related to labor.
What's that?
It was related to labor.
Yeah, we had just the one input was one thing, right? So we had one input, and it was constant, right? And constant productivity, which gave us our straight line production possibilities frontiers. Okay, so now we're going to add on to that a little bit more. So comparative advantage depends on a country's endowment of multiple resources. And we're going to allow for quality differences, which we didn't do. but we can start to allow for quality differences in labor, for instance, across countries. And so our first one we're going to look at is called the Heckscher-Ohlin model. The HO model. So the Heckscher-Ohlin trade model. All right, and it deals with factor abundance. Factor abundance versus factor scarcity. Factor abundance versus factor scarcity. So if we think about capital and labor and land, you know, what are we rich with? What are we abundant with is going to play a role in this model. So when a country enjoys a relative, that's kind of the comparative advantage part again, a relative abundance of a factor, the factor's relative cost, is less than other countries where it is relatively scarce. Okay, so let's take a look at the U.S. and Mexico. Draw a little four-square thing, similar to what we did with comparative advantage in Ricardo. But let's measure capital here and labor here. So machines. So now we've got both factors rather than the outputs. And we've got the U.S. and Mexico. So let's say that the United States has 200 machines, or 200 units of capital. Mexico's got 20. The U.S. has 600 workers, and Mexico's got 200 workers. So thinking about factor abundance of one country relative to the other, how would you start to maybe use these numbers? Think about factor abundance.
Well, it's obvious that the U.S. has a larger pool of labor and
Okay.
a lot more capital than Mexico.
All right. Yeah. So kind of similar to the Jakarta U.S. deal, like we had absolute advantage. It looks like, I mean, we are kind of dominant here with machines and workers, right? So we're kind of the bigger player. What else?
You gotta put in the ratios.
Okay, so put in the ratios, what will that do?
It makes them comparable. You can see which one has relatively more machines to workers, more workers to machines.
Okay, So the relative part here, so when a country enjoys a relative abundance of a factor, the factor's relative cost is less than when the other countries where it's relatively scarce. So we're looking within our own country first and then comparing to another country, right? So if we look at the capital to labor ratio, so if we just take one country here, if we take the United States capital to labor ratio, we've got 200 machines for 600 workers. Giving us a third of a machine per worker. So every worker has a third of a machine. And in Mexico, we do the same thing, and we've got 20 machines with 200 workers, giving us a tenth of a machine per worker. Relatively speaking, who is more capital abundant? United States. We got more machines per worker. And so what would be your prediction about how things would get done in a country like this? Mostly automated, right? There's more machines. So when we think about the big question of the trade-offs involved with the production function, so if we're in the process of making basketballs and we input a certain amount of machines and a certain amount of labor, there's a number of different blueprints we could use. We could go with a more labor-intensive method, or we could go with a more capital-intensive method. I've told some of you this story, real interesting, when I think I was actually down in Mexico, matter of fact. No, I was in Cancun, I think, and I met this guy with a accent from kind of Eastern Europe. Got to talking to him, and he was an older guy. I think he was in his 60s or 70s, and he told me a story when he was working construction over in Eastern Europe during the 1950s. It was, different period of time where there's a lot more non-free market over in Eastern Europe, and they had to clear some land, right? They had to go clear some land, and for them, since there was government controls on machines and labor, it was better for them to clear. Imagine clearing a ground. I can't remember how big it was, but I just remember it being big, like all of OU. And we need to level it, so the terrain needs to be prepared, like we prepared the pad down here for the construction. They got 1,000 people with 1,000 shovels to do that job, and that was more cost effective than getting one person and one machine. So there's choices to be made on what type of method we take. Now that one was due to government circumstances. Even if both countries are free market, we're still looking at what is the relative abundance of labor and capital. But it can be done, so don't forget that there's choices out there. As Americans, we kind of tend to be a little more single-minded, like, oh, well, we got to get a lawnmower if we're going to mow the lawn. Well, there might be other methods that we can do. We're just used to having a lot of machines lying around. Okay, so I shouldn't be afraid to embellish the story. It was more like 10,000 workers, not 1,000 to do it. It was an unbelievable amount of labor because they were all just available for close to free.
Being paid by the hour?
Yeah, or they were already on some sort of government program or something. So yeah, they were all available, waiting in the soup line anyway to go do it. And so they just had 10,000 people do it. Okay, so therefore, the U.S. is capital abundant relative to Mexico, and will tend to have a comparative advantage in capital intensive goods. So the factor from which you are abundant with leads you to capital intensive production methods. Wish I could get this little cough to go away. All right. Got that. Why is the production possibilities frontier bowed outward? The real production possibilities frontier. John?
Because some resources are better suited to do other goods, and as they are used to make the less efficient good.
Okay. So if we think about the endpoints of the production possibilities frontier, and so in reality we expect this thing to be bowed out. We haven't been drawing a lot of bowed out ones for a while. And here we're still measuring our goods. What are we doing? Yeah, actually I got a little, I'm going to do computers and toys. Yeah, not labor and capital, sorry. So, yeah, you could draw a big one. You know what I say? It never hurts to draw a big one, even if you might sneak in a few comments. I just kind of ran out of board space, but. So, what's going on at these endpoints? Well, we have a fixed amount of land, labor, and capital, multiple types of resources, and some resources aren't as needed for one good or the other. And so as we put all of our resources into this production point here with 0 toys, we could get a lot of toys by just moving a little bit this way. So the whole idea of increasing returns in toys could kick in. Eventually, of course, diminishing returns will be there. But as we move along here, we get a whole bunch of toys, and we only have to give up a little bit of computers, right? So we get a lot of bang for our buck. As we continue to move along the frontier, we get to this equally obnoxious point where another toy is fairly costly in how many computers we have to give up to get it. So some resources are better suited to the production of one good or the other, is the answer that John gave, and I'll buy that. Some resources are better suited, more productive really, better suited for the production of one good or the other. So we don't have that equal productivity thing that we did before, and we get a bowed out production possibilities. Okay, so what is the slope of the production possibilities frontier? Change in computers over the change in toys, right? So at one particular point, if we measure the slope of the line, which is a tangent line just touching point A, so if this country chooses to be at point A, then we've got the slope of that line being the opportunity cost of whatever you're measuring on the horizontal axis. So the rise over the run thing says if the slope of this line is 4, then I give up, as you were saying, Max, give up 4 computers and I get 1 toy. So the cost of a toy is 4 computers, right? So that gives us our trade-offs along there. All right, so when we opened up for trade in the Ricardian model, prices changed, right? So each country had a different starting place, and when we opened up for trade, they changed. So if we're currently at point A in the, I don't know if I want to call this the United States or whatever, but if we're currently at point A, maybe this is China or something, the direction I'm going to go, that'll tell a better story. If we're at this quantity of 100 computers and 60 toys, and the terms of trade, if that was a slope of 4, if the terms of trade are 7, so imagine a terms of trade line like this. So this is the terms of trade, TT. We've got some possibilities to make ourselves better off. What can we do?
Until the point where the terms of trade is the tangent line to the curve.
Okay, so why can't we go to this point? Okay, yes, but we can try to do that with trade.
It's not feasible. We don't have the resources, right, to do it. We can't produce something like that. It's outside our possibility.
Yeah, if we have this many right here at 60, it's possible that we could get rid of a couple of them and go up here, right? I mean, that's possible. But if I do that, I'm doing it at the expense of toys, right? So we're still doing a trade-off. So internally, if I produced them, I could only be up to here. I can trade to get up. I give up this many, I get up to here. Okay, so I just want to make sure that that's possible. I can move from A to this point. But what would even be better is to do what? How could we even do better than that? Right. John said the right thing. So we're producing currently at point A. What could be better? Because wouldn't it be better to have more of both goods? Yeah, we learned that a while back. It'd be nice to have more of both.
So we're trying to avoid the trade-off.
We want to work, well, it depends on what trade-off you're talking about, but we want to work with what we could do
We want the maximum
with our own trade-off.
computers and toys.
Our production possibilities are here.
Use the point where that line is tangent to the curve. I don't know. Can we move that line at all, or is it?
Okay, good question. Can we move that line? Is that a shiftable line, or can it shift? As long as the slope stays the same. Excellent. Why? What is the slope? It's the world price. It's given to you. So it is really the world price. So it's more about it's what allows you to trade rather than anything to do with production at all. Now I put it through this point because it is possible for us to take our existing quantity and get to this point. We can trade our existing stock of goods, give them up, and move along the trade lines. And yes, it's true, we are outside of our production possibilities by doing that. So that's kind of cool. Potentially makes us better off, by the way. Taylor?
We want to move that line out and produce where that line is simply movement.
Okay, and so what I want to be careful about is, what are we really doing when we're moving the line out?
We're reallocating our own resources.
We're reallocating our own resources. So we're not really moving the line, but we're moving our production point. Okay, so now we're going to move our production point until we've squeezed out all opportunities, which are given to us by the world prices. And all we're doing is we're chasing that football region. We're just chasing that gap between what our costs are and what we could do on the world market, right? So we're just squeezing that gap out, and by doing that, we are moving along the curve to wherever that sucker is parallel to it. So we're going to change production from point A to B. And now we're going to trade to wherever we want to be. And now we can be at a point like C where we have more toys and more computers. Definitely a better spot. There's no way we could be outside of production possibilities frontier and have more of both staying where we were at. So it's a little extra twist on what we did before. Okay, questions there?
So could you like write a caption of what we did with, like in words?
Sure. So what we get away from is that unsettling, unrealistic assumption that we had with the Ricardian trade model of full specialization. I make all the food, you make all the cars. I make all the fruit, you make all the, what do we have? Computers, right? I make all the toys, you make all the computers. We're getting away from that because we're just having specialization up to this point. So there's still a mix of both going on. So it's kind of a partial specialization. All right, so HO model gains. So number one, seems like it's running out already. Number one, at autarky, compare world price compare the world price to opportunity cost. If world price does not equal your opportunity cost, then there are gains to be had. Then there will be gains from specialization in trade. So move from point A to point B. Move from A to B such that the world price, which is our TT line, remember, such that the world price is tangent to PPF. Now, world price equals opportunity cost. And we've exhausted all of the potential gains from trade at that point, which is our point B.
the opportunity cost is the same thing as the world price, or not?
The opportunity cost is always the slope of the
Slope.
production possibilities frontier. So they're two separate things. The world price, maybe I'll highlight that. That's a slippery point. So note, world price is given by the world, of which you're a part of the world, but you're not making it. So world price is given. Opportunity cost is given or determined, maybe it would be a better word to use there, is determined by resources and technology. And that is the slope of the production possibilities frontier. In equilibrium, the two are equal to each other. So they are coinciding with each other. The slope of the production possibilities frontier at point B is this line, which also happens to be equal to the world price. So that's kind of our first order condition. All right, last step then is to just trade for the good you don't have. Trade for the good you don't have a comparative advantage in. Which means you're going to move along the TT line to point C or wherever you decide to land. Okay. Any other questions on that?
Talking about international trade, the slope of the tangent line is the marginal rate of substitution, right?
Yeah, getting back to kind of intermediate
Yeah.
stuff. Yes. So in intermediate class, we had a closed economy. We didn't necessarily have international trade, right? And so we had that top level condition was an indifference curve that satisfied everything. And so where those two were equal, we had equilibrium. Marginal rate of substitution equaled the marginal product, the marginal rate of transformation, which was the slope of the PPF, the opportunity cost. So yeah, that was all very similar.
So that was on a micro scale, this is a macro.
Yeah, so now the only difference is that the world price is reflecting the globe's preferences through the supply and demand of Japanese and Germans and Italians, and some sort of big world supply and demand curve is determining the world price of that good.
But they're similar, the marginal rate of substitution and the world price.
Yes.
They're based on prices.
In that the world price reflects what people were willing to buy around the world. So yes, it kind of reflects their preference for that good. Because marginal rate of substitution, you're getting into the utility business, right? And so that price, in as much as it reflects the benefits that the world is getting from having soybeans at $8 a bushel, then yes, it is reflecting the marginal benefit of those goods to the world. Okay, number two big part here. Paul Samuelson is a Nobel laureate in econ, and a long time ago when he was noodling this international stuff, he worked with a guy named Stolper, who I don't really know much more than his name, but and there's a result that he wrote about in a journal article on the effects on wages and who gets helped and who gets hurt in this factor abundance scenario. So I guess, I don't know, I put a number 1 on that other thing. I don't know if this is Stolper-Samuelson Theorem. So here's some assumptions of it. Number 1, labor earns wages proportionate to skill. Labor earns wages proportionate to skill. Higher skilled people get higher wages. Owners of capital earn profit. Owners of capital earn profit. They could also earn rent. Well, that's why we did it this way, because the land is, we're going to have the rent accrue. Landowners earn rent. So we got labor getting wages, capital owners getting profit, landowners getting rent. And the amount of income to each depends on both the demand and supply. Of inputs. Recall from days gone by that the demand for a resource is a derived demand. So we called it a derived demand curve. Does anybody remember why? So the demand for labor, for instance. We say that the demand curve for labor is a derived demand curve. What's it derived from?
Aggregating it?
What's that?
We're aggregating all the labor and kind of drawing a conclusion from it or something?
No, we can stay at a micro level. We can stay at almost within an individual firm. Ultimately, it might be aggregated up, but we don't have to.
It comes from the demand for the firm's products.
Okay, so the firm's product, yeah. So a large part of the demand for labor is the fact that they want to buy my computers, right? So I demand people to work for me because people demand my computers. So the demand for labor is derived from the demand for the final output, for the final product. So recall, input demand is a derived demand. So it comes from final product demand, in part anyway. So we had the, there's a couple different ways to put it. I guess we use the value of the marginal product. Put a little teeth on this, which basically said that the demand for labor, let's say, is equal to the marginal revenue of the product that they do times the marginal product of labor. So the worker comes to work for us and does a physical process. The marginal product is the change in product that one additional worker makes for me. How many more hamburgers did I flip? How many more computers did I make because I hired that one extra person? Marginal product. That only helps me if I can sell that product. So the marginal revenue is the change in total revenue from the change in extra product. Right? So marginal revenue is the change in total revenue from the change in quantity. These two components together tells me what I'm willing to pay somebody, the demand for labor. And the same is true with other inputs. And so now you can kind of see it all tied together here, that the delta Q's cancel out. And so how much I value somebody at my company comes down to the change in revenue that that person adds by bringing them aboard. Right? So that's the derived demand part that enters into this. Okay, so the Stolper-Samuelson theorem. Woo! Wow, we're having so much fun. We are not going to get to that theorem. We will pick up there. We'll leave you hanging unless you do a little bit of reading. Chapter 4, the suspense might kill you, but Monday we will think a little more about the Stolper-Samuelson theorem.